Today we are going to talk about functions and type of functions. What is a function? A function is a relation in which each input has only one output, meaning for every x value that you have only one y value. So if I plug in a number such as x equals 2 into an equation, I can only get out one answer for y. So doesn't matter what that answer is, but there will only be one answer for y, which means I can't plug in a 2 and get a 3 for y and a 4 for y. That would not be a function. I can only get one output for every input that I plug in. So thinking about my t-charts, I can have whatever numbers I want on this side, but those numbers, so let's say if I have a 2, I can only have one answer over here for that 2. Maybe it's a 3. If I have a 4, I can only have one answer for that 4. Maybe that's a 5, or so on and so on. There are some times where the x's might repeat again. So if I have a 2, if there's another number right here that's besides 3, that's other than 3, it is not a function. So if this is a 7, then this answer does not represent a function because I have two values of y for the same input. For this input, I have two outputs, and I'm only allowed to have one. This is what that will look like in a t-chart or an equation. What will that look like in a graph? In a graph, again, our x values are the horizontal value. We want to use a vertical line test on graphs to see if it is or is not a function. So if I have a graph and that has like an image like this on that graph, right? I want to use a vertical line to determine, does that only hit one point on the graph at a time? If I draw another vertical line here, it only hits this one point. These end pieces look a little bit different because, again, if they're facing straight up and down, then if I draw that vertical line, it's going to hit multiple pieces. But if they're facing out, when I draw that vertical line, it's still only going to hit one value. So the way I can tell whether something is or is not a function is by drawing a vertical line and seeing, does it hit more than one point or does it only hit one point? Let's look at an example of this. So we have three examples right here. Are the following functions or not a function? So again, if I were to take in through each one of these points, if I were to draw a line, and that line is, if that only touches one point at a time, then my vertical line test passes, which means yes, this is a function, right? However, let's say that there was a second black dot right here. When I draw that vertical line, notice that it hits two dots at the same time, which means that would not be a function. Now, obviously, I just added that dot. That dot wasn't originally there, so if I were to erase that dot again and draw that vertical line, then it is a function. Same thing here. Now, obviously, there are no dots on this one, but if I were to put dots on this one, again, any line is made up of a bunch of dots. And if I were to draw a vertical line going through that dot, it only touches one point. So we're good. If I were to draw a vertical line through this dot, it only touches one point. So then again, that this is a function. This one is a function. On your homework, please make sure that you write function, not just yes or no. Last one over here, again, if I were to take and draw that vertical line through any point on here, if I were to draw that vertical line right here, notice it hits 2 points. We don't want 2 points, we only want 1. Same thing if I were to draw that vertical line here, it hits 2 points, which means because it's hitting 2 values and not just 1, this one is not a function. So that's how to tell the difference between something that is and is not a function. Now let's look at what function machines look like. So a function machine basically is this like wonderfully drawn like little machine box that has a function inside. Notice the function is like an actual equation. The only difference is instead of saying y equals 5x minus 3, this says f of x. F of x is function notation, but it still just means y, or the output. Notice up here they give you this number 3. That means this is the number that they want you to plug into your equation. So imagine taking this 3 and right here plugging it into the notation, which means you want to do 5 times 3 minus 3. So 5 times 3 is going to be 15, and then 15 minus 3 is going to give me 12. So if I take and I plug in a 3, I am going to get out of my function a 12. Same thing, notice here, it says f of x equals 3x plus 4. They're telling me, what if x equals 3? So that means anytime I see an x, I'm going to plug in a 3. So now we want to figure out, well, what does that answer actually equal? If I plug in a 3 for this f of x, what will I get out? 3 times 3 is 9. 9 plus 4 is 11. Sorry, 13. I'm so sorry, 13. So we're going to get out a 13. If we plug in a 3, we will get out a 13. I can keep going here and I can decide another number. Let's say I'm going to use this. Notice this says g of x instead of f of x. So let's say that they tell me I have a g of 5 or 4. So that means anytime I see that formula, I'm going to plug in a 4 for that x. So right here I'm going to take and I'm going to plug in a 4. 4 minus 1 is 3. 3 squared is 9. So if I plug in a 4, I will get back a 9. That is a function machine. Now let's look at some examples of those and what it will look like as you complete the assignments. It says evaluate the following expressions given the functions below. So notice we have 4 different functions. And notice the front part of each of those have a different specific notation. This one says g of x, this one says f of x, h of x, and j of x. We want to pay attention to those because down here we want to know which one am I using. This says g of 10, which means I need to find my function that starts with a g and I need to plug in a 10. So I'm going to take this equation that's a g, and I'm going to rewrite it, except this time I'm going to plug in a 10 instead of my x. And then I'm going to solve. So negative 3 times 10 is negative 30. Negative 30 plus 1 equals negative 29. I'm going to do the same thing for this one, f of x. So I'm going to find the one that says f. And I'm going to plug in a 3. So I'm going to do 3 squared plus 7. Well, 3 times 3 is 9. 9 plus 7 is 16. And I can keep going. Notice this h of negative 2 means I'm going to plug in a negative 2 right here and do 12 divided by negative 2. This j of 7 means I'm going to plug in a 7 here. And so on and so on. So then anytime I see my function notation, the number inside of the parentheses is that number that I'm going to replace the variable with. All right, the last part of this lesson is different types of functions. Make sure that you write these down. So we have 8 different types that we're going to talk about now. There's more, and there's more specific ones, but these are the ones that we're going to focus on as we go throughout this next 20 days. So we have linear functions. Linear functions just mean a line. So imagine you have your diagonal line, you have a horizontal line, you have a vertical line, something with just a single x in it, y equals x. You have a quadratic function. A quadratic function is also known as a parabola. That's the one where you have a U shape. Again, the U shape can be facing up or it can be facing down. But that also means that instead of having just an x, we now have an x squared. A cubic function, cube means 3, so instead of having a squared, we now have a cube, like this. And the graph of my cubic function is going to kind of look like a sideways S. It's going to have the part that goes up and then the part that goes down. A square root function, again, that will be anything with the square root, so we would have like the square root of x for our equation. Our graph would have a starting point and then it would curve. So it would be almost like a quadratic or cubic function where it does have a curve, but it doesn't have an ending point. There's only one single starting value. Absolute value. We have our absolute value sign, so those are our 2 parallel lines with our values in between. The absolute value looks like a V shape. So there is no curve in it. It goes straight up on one side, straight up on the other. There are no negatives in an absolute value. A trig function is our sine, cosine, and tangent. So when you write your equation, you will have one of those in it. For right now, we will just use sine x. And again, there's multiple looking graphs for this. Our sine is going to look like this, and it's going to be a continual graph with arrows on the end, but it curves like that. Our cosine graph is going to look like this cubic function where it curves, but there will be starting points and stopping points. So it might look like this, and it has several of them because it has a beginning and an ending point. An exponential graph is a graph that has an exponent as the x value. So you might have y equals and then like 2 times x. So as opposed to this one up here that has the x and then a squared, this one has the x as the exponent. That exponential function will be smaller, and then all of a sudden it will increase very fast. So it will have an almost like flat surface and then go up, or vice versa, go down. And then last but not least, rational. You're going to have a graph where it has asymptotes. You're going to have a fraction where it has some sort of x value at the top and some sort of number or x value at the bottom. So maybe like x squared over x or something like that. And this one, again, you're going to have asymptotes. So it's going to look like your curved function, which is your exponential function, but there will also be a second part that curves the opposite way, like this. So these are what your different graphs, different functions of graphs, and the equations of those look like.